Yes, it's another draft physics video production. Dun, 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 dun. More microphone. Well, I won't bother doing that. Maybe I'll bother. Alright, it's a little tiny bit closer. Anyway, yeah, I'll have to fix that someday. So I did get my solar panels finally hooked up into the basement, so I have some solar light now. Something's falling over there. Anyway, working on it. Life, whatever. The other thing I thought I would just, the other thing, it's not really another thing, just point out that I think I'm ending the $3,000 blah 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 contest because it really didn't do anything it was supposed to do, which was help create some sort of interest in the channel and all that kind of stuff. And nobody's entered in months, and so what's the point? Better to use whatever resources I have to bribe some physicist to be humiliated by me. Yeah, that's what they will be. Um, I just asked them things like, how does an electron not fit the definition of a magnetic monopole? And they're going to have to sit there and just look stupid and say, I don't know. Because it's perfect. Anyway, it's that kind of stuff. I mean, that kind of stuff just makes it obvious that they've never really thought about any of the stuff they say. They just say this stuff, and they have not really thought about it at all. They've really not considered alternatives. They just get what they're preached, and that's all they hear, see. That's it. Doesn't go any farther. So anyway, speaking of people who just don't think much, Ken Wheeler fans, I figure I'll do a Ken Wheeler video. Just because it's there. And it's so stupid, and it doesn't say anything, and it doesn't explain anything, and it gets hugely rewarded. 378 thumbs up. I can't hit 10, right? And 18 thumbs down. Just amazing affirmative numbers for absolute crap. I mean, it just can't be any crappier. It's just perfect. Just as much as electrons and protons are perfect descriptions of magnetic monopoles, this is a perfect example of crap. Crap science. It's just amazing that people eat this crap. It's just amazingly sad and depressing. So anyway, on with the show.
Okay, smaller space, the higher the capacitance. Let's repeat
Okay.
that 2 more times.
Yeah, it says that the smaller the space, the higher the capacitance, which means absolutely nothing. It's just gibberish. Capacitance is a kind of a word, okay, we use for different things. It just kind of has to do with, how much can this cup hold? Um, you know, and in physics, there's nothing about small spaces that mean anything until you're compressing something. So yes, if you take a volume of air and you compress it, you'll have more air in a smaller space. Yeah, that's hardly miraculous. It's not in dispute by regular physics. It's not an interesting statement really at all. And it has nothing to do, there's no capacitance in any real sense to something called a photon. It's a category error.
The smaller the space, the higher capacitance, the higher the capacitance. So now let's draw some infrared light here. There we go.
All right, and so he buys into some argument that there's some sort of two fields being perturbated by this whatever, and that somehow they're equal, which they're not. Again, the magnetic field is divided by c, not c squared, but c, divided by c, divided by the square of light, weaker than the electric field. Yet they draw it like this, which, it's more lying, just lie for the fun of it. Who cares about being at all accurate? But it's literally a million times smaller, the magnetic field. Literally.
And of course, that is an extremely crude approximation. Up here on top, We have frequencies towards the ultraviolet. Yeah.
Yeah.
Say
Yeah.
UV
Yeah.
here, blue in spectrum, green, orange, all the colors of the rainbow. And over here we have red light.
I don't see any yellow, so but whatever. Continue.
Yeah, and towards
Yeah.
red.
Yeah.
So
Yeah.
here we've got some red light, and now let's.
Yeah. I guess I'll give you more volume because who knows? Might not be able to hear him.
Let's draw some blue end spectrum light. This is not to scale. The difference is actually quite drastic.
All right, so he says this isn't the scale. The difference is quite drastic, as if he's underdrawing the difference. So means this just demonstrates how little he's actually thought about this. I mean, he claims to have read every book and everything, and yet he doesn't understand just intuitively now, just as a reflex, as I do, that infrared's half the wavelength of, it's twice the wavelength, or one half the intensity, if you want to use, because it's in the number of cannonballs, quite obviously. The lumpy things are the things that give the thing, capacity to do something. Without the lumpy things, it can't do anything. Now I'm saying the lumps are particles. We don't need the lumps at all. We don't need this curvy line crap. We don't need any of this stuff. But regardless, if you believe in lumps, lumps are the thing that are something. That's the pressure. Okay, so obviously if I have twice as much pressure in the same length, that would be more intense. Ooh, is that a shocking observation? But just see how he doesn't even intuitively know that if it's 4 lumps for infrared, then there'll be 8 lumps for ultraviolet. That's all, just 8, not 74, not 468. It's only half. And then when you go to something like X-rays, that's when you get into it's 100 times more. So it'd be 40 instead of 4.
Excuse my poor.
It might be more than that. It might be 1,000 times. X-rays are 10 nanometers. Infrared is whatever, 700. And blue is 250. You could go to ultraviolet 250 or something. Be the limit. So it's 250. It's 25 times.
Handwriting here. It's hard to draw this many waves.
So again, it's hard to draw this many waves. You're drawing way too many. You way over exaggerated the difference. So just show your ignorance. Thank you. Prove my point.
Anyway, so which of these do you think is more powerful?
So what do you think is more problematic? A cannon, the enemy has a cannon and it shoots cannonballs every second. And then they get a new cannon and it shoots them every half second. Which cannon do you think is more effective? Oh yeah, the one that shoots twice as many lumps at you. That's right. Yes, obviously there's more intensity for the same amount of time that can be delivered by ultraviolet light than it can be delivered by infrared light. No surprise. Nobody should be in doubt.
Let's take a look at light. And by the way, we need to drop a little equation here, and you could look this up anywhere.
So he got these proportions preposterously wrong, and now he's going to do math for us. Sure he is.
Energy equals nu F. Energy equals Planck's constant times the frequency.
And it's just a nonsense formula. It doesn't mean anything in the sense that the frequency is only defining how many cannonballs there are. Obviously, how many cannonballs are going to decide how ruined your house is, right? So how many little lumps hit your house is going to decide how smashed your house is. There's no doubt about that. But there's complete doubt about how it has anything to do with anything other than the fact that it's just more cannonballs, and that's all it is. The cannonballs aren't any different. Same cannonballs.
In electrovolts, ultraviolet and spectrum light.
It doesn't have an electric voltage. Light is not a voltage. So you're just now, again, they're making another association. Because it has a consequence, we're going to pretend it actually directly causes the consequence, when no, that's an effect. And the effect can be variable. Like how much it moves an electron is variable, because the electrons are always held in a position by some other force, and you have to break them free of the things that are holding them. Oy.
It averages 2.95 eV volts, 2.64.
So he's writing these numbers that are going to show him that, oh yeah, what I'm talking is shit here, because this is only half as much as that, not 4 million times as much.
Green averages 2.3, and right at about 2 and 1.7. So we got 1.7.
So he's pretending to have memorized these numbers in some way, but he hasn't memorized the fact that this number is like half of that number. Yeah, he hasn't figured that much out.
7 on the near end, depending on how you look at it, or the far end of the.
Did I point out Ken Wheeler's a despicable coward? I mean, so all the people who think Ken Wheeler's a hero, why don't you ask him why he doesn't debate a live person instead of debating dead people, which are pretty easy to bury them, right? It's pretty easy to bury the dead. It's a little harder when they got a little bit of life in them, okay? But, specifically I would, just love the opportunity to challenge Ken with a couple of questions. But why doesn't he do that? Why doesn't he play somebody else's, a living person's video? And that is a living person who obviously will respond. I mean, all of us don't like Neil deGrasse Tyson or all the other talking heads of physics, but they're all cowards too, so they'll never show up for a debate. They'll never put themselves in jeopardy, so there's no hope of that. But so why doesn't Ken take on somebody who would be willing to defend their theory or their arguments? Why does he debate dead people only? If he's such a competent and undefeatable, unchallengeable adversary, why is he such a coward?
This is, of course, all visible light, right? Visible light. And towards the...
well, it's obviously not all visible light. Ultraviolet isn't visible, and infrared isn't visible. So, wrong again, Ken.
Ultraviolet end to the blue end of the spectrum, we have basically 3. We got 1.7. We almost have twice. And
yeah, so he just figured that out all by himself, even though he drew it completely wrong. 4 and it should be 8. And I mean, instead he did whatever, 67.
And this is the volume here. Let's take a look at blue and spectrum light. Let's just take a look at one little section of it here. We got this for volume, as opposed to, of course, this for volume.
Alright, so he doesn't even draw the same thing. He draws 2 lumps here, and he draws 1 lump here. Wrong. And, of course, these proportions are wrong. So, yeah, okay. Illustrate it wrong. Fine.
So you would think that this would be more powerful, right? And of course...
No, why would I think that? Why would I think because there's less cannonballs it's more powerful? Why would I think because there's less lumps? There's no reality in these proportions, in the sense that not only is he getting the idea of the lumps in wrong proportion, there's no assumption that you have to make everything bigger. Now, I would argue that the polarization actually does increase, but that's because the time increases, when you shoot them. So if you shoot them every half second, they end up coming out of the cannon straighter, because the cannon moves less in between shots. And that's sort of the argument. But it has, again, nothing to do with this nonsense. Again, he's taking conventional theory, conventional mush, and saying it's true, when it has no more credibility than any of the other crap he says can't be true. And he's certainly not explaining how it's not true.
Just the actual nature of light is the longitudinal pulse perturbation.
Well, then why don't you draw a longitudinal pulse perturbation, which would be a line like this, and then a line, and then a line, and a line. Is there really any evidence anywhere that light gets stronger and then weaker and then stronger and then weaker and then stronger? Is there any evidence of that? No evidence of that. Do you have any evidence or experiments or any theory regarding how long, how what's how exactly the light turns on and then turns off and then turns on and then turns off? Do you have any experiments that demonstrate that?
And right here, this is where the dielectric pulse perturbation, rarefaction, compression, it's at its greatest.
So he's saying the nodes where there isn't a lump, where there isn't an expansion in the field, is the strong point. So the point that would be the dead line, a straight line with no this in it, is the part that somehow has the energy in it. Now, I would argue that drawing those little dots just basically says, yes, the nodes are all there is, and there's just a distance between the nodes, and the nodes are cannonballs. They're particles. They're little bits with momentum because they're moving the speed of light.
Is where the electrical and magnetic component are at their greatest, is where the dielectric is at its minimum, or
there's no the dielectric, again, we have no understanding. There's provided nothing ever, any explanation of what a dielectric is. There's no such thing as a dielectric except for a substance. Substances are dielectric. That is, they hold charge on the surface but are insulators. That's the definition. There's no substance in this thing. There's no dielectric in it. There's no surfaces to be charged. It's just nonsense.
And the zenith of the dielectric is where the electrical and magnetic are at their nadir. So inverse when
at their nadir, yes, when they're zero. So when nothing's happening, he's saying something's happening, and when something's happening, nothing's happening. Got it. That makes sense. To idiots, not to anybody with a brain. I mean, you can't have a functioning brain and say that makes sense.
Another, of course, this is. Like I said, everything in the universe is the right-hand rule, so the...
What does this have to do with the right-hand rule, and where are you going to show me the right-hand rule? There's no right-hand rule here. The right-hand rule is a complexification created by atoms. It's not created by photons. Photons don't tell stuff, I have to go right. Photons don't do that.
The smaller the space, the higher the capacitance.
So again, more nonsense. The more the space, the higher the capacitance. He meant to say the less space, the higher the capacitance. So he didn't even say his own, he read his own script wrong. He did just say that, right? The more the space, the higher the capacitance. I mean, he didn't even say his own catchphrase. He can't even say correctly.
Verse is the right-hand rule, so the smaller the space,
the
higher the capacitance.
My fault.
The smaller the space, the higher the capacitance, right? I don't know how many times I need to repeat that. So everything in the...
Yeah, so it just means nothing. Everything in the universe is this nonsense about small spaces being bigger things, and they're not. Obviously, as pointed out, pressurizing is everything. So if two electrons are here, they don't repel each other much. If they're here, they repel each other more. If they're here, they repel each other more. So that has nothing to do with the space per se, technically. It's nothing about the small space creating the problem. The problem is they're radiating something, and the radiation is hitting them harder. So it's just like me taking a fire hose and shooting you from 50 feet, and then me shooting you with the same hose from 10 feet. Guess what? It's going to hurt a lot more at 10 feet.
The universe, when it pertains to power, specifically, the dielectric is the smaller the space, the higher the capacitance.
So again, it has nothing to do with its capacitance. And frankly, when you get to certain small spaces, there is no more capacitance, and the whole thing blows up or breaks or doesn't function anymore. So again, it's just kind of nonsense.
Said that 1,000 times, but it's so incredibly important. Here we actually have a mass, and here we have a non-mass, which I actually made a dot just to represent where a mass would be. Yeah.
Okay, it's a non-mass, but I'm going to put it there with a dot for the non-mass, whatever that would be, whatever a non-mass would be.
Okay. We're going to talk about a black hole. Do you know what a black hole is? The only way you could actually
So I don't know why he believes in black holes. Is there some shocking evidence that tells you that there's such a thing as this highly compressed matter. And then why would you, well, I'll let him say it, but I mean, why would you have why would you assume that because you've merely compressed the matter that somehow you've made it ungravitational or everything that it used to be? It's still going to be the same stuff. You just put it closer together.
Accurately ever explain Mother Nature or Natura Naturan?
Natura Naturan, which is basically what's saying nature, or nature naturally, or naturally nature.
Is in those simplex of terms, because if Mother Nature...
Again, it's just more simplex terms. There's nothing simplex about this mushy language.
Sure, we're a chick. She'd be a hairy armpit chick with muddy feet and a hemp skirt. So here we have a mass.
No, she would be worse than that. She'd be brain dead, because even the hairy-armed whatever monkey woman, okay, given a tiny bit of knowledge, wouldn't kill, mass murder billions and billions of little children every day, little baby animals every day. Yeah, no. Nature's a lot worse than a hairy armpit, smelly woman.
Now, as I've told you before, mass and volume is the same thing.
Mass and volume are the same thing, even though we pick the words to describe different things that have clearly different properties and attributes, and that's why we used a different word to describe them.
As saying magnetism. Yeah?
Yeah, I don't see that. I'm sorry. Volume and mass doesn't mean magnetism to me. That doesn't really explain two poles, different functions, different understanding electrons and protons. Well, that sort of explains magnetism. Two charges put together, two opposite charges smashed next to each other, create what's called a dipole. There you go. Magnet.
Let's actually take a look at a magnet here in a second, right? North Pole and the South Pole. Over here we have the so-called black hole. It has a mass, I think what the minimum mass of a black hole. Of course, these are not approximations. Since I'm drawing on an iPad here.
These are not approximations, since he's drawing on an iPad. No, they're just pulling out of your ass nonsense. I mean, some vague notion you have. Black hole theory applies to anything. You can turn anything into a black hole. I could just turn this little bit of mass into a black hole. The point would be is I take this entire mass and I make it so tiny, tiny, tiny. That's a black hole. So black hole theory doesn't sit there and say you can't have a black hole that's very, very small, or one that's a billion stars worth.
Oh, something to the order of 10 to the 50th power? 10 to the 50th power, greater amount of total mass than the supermass we have over here. This would be like representative of our sun, and here's the supermass right here.
Our sun is a supermass. I don't know what that means. Our sun is here. It's a supermass. This is the black hole is supposed to be over here. I don't know. What's he talking about? Do you know? Nobody could know.
About 10 to the 5th power. I think it's actually 10 to the 10th or the 15th power. It's not the 5th. 10 to the 10th power, somewhere around there. Greater than the mass of our sun. But over here.
Yes, you have black holes that are made out of a lot of solar masses, as they're called, just as a way of not having to go 4 zillion pounds. So you call it a solar mass. And they have solar mass black holes that are 1 solar mass, and solar mass black holes that are 1,000,000 solar masses. And it's nonsense, but whatever. Blah, 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 blah.
Here we actually have something that's 10 to the 50th plus power, greater than the mass of our sun, but it is something that is...
So, I mean, blending black holes and magnetism just is... It's a category error. It's like blending paper clips and pigeons. Just, what are you talking about?
Supermassive, but has... In other words, it has an enormous amount of mass, but has no magnitude. But magnitude...
So again, you know, where in black hole theory is there any notion that it doesn't have any magnitude? You know, that black holes aren't a threat. You know, that I can take a solar mass and crush it down to the grapefruit size, and somehow it still isn't a solar mass when it clearly still is. From the distance of the sun, that is the sun's circumference presently, if I was to go to that same location away from the little black hole, there would be the same amount of gravity as the sun. It's still a place that stuff falls into. You know, what do you mean it has no magnitude? It just doesn't make, it makes no sense. It doesn't, why bother creating black holes if they have no magnitude? Why would they be relevant? And how could we ever see one if it had no magnitude? It doesn't make any sense. What he's saying doesn't make any sense.
Dude, when we say mass and magnitude, we're literally almost talking about principle and attribute here, but specifically getting down to brass tacks, we're talking about something that's supermassive that has zero magnitude.
And again, how does that make any sense at all? How do we see it then? If it has no magnitude, isn't its magnitude its presence, its existence, the fact that it does cause gravity? What do you mean it has no magnitude? What is magnitude if it doesn't mean you make gravity? If you don't make gravity, and you don't reflect light, and you don't do this, and you don't do all these things, then how can you have no magnitude if you do those things? And black holes do those things. I mean, they don't reflect light necessarily, but they certainly emit radiation.
This is where dielectricity is thrown, magnetism's ability to keep something within the visible universe. Like in the power lines outside of the back of your street, the closer you bring those lines together, the greater the voltage, the greater the capacitance.
So that's more nonsense, so that didn't make any sense. You bring power lines together, you don't increase the voltage. You just increase the likelihood that you'll have a discharge between the wires. Is there anything else that's the truth? And if you're in space, you don't have to worry about it.
The further you spread them apart, the greater amount of magnetism you can actually store within the system. Yeah?
No. No. Not a yeah. A no. No. You're wrong. That's nonsense. Prove it. Show me the experiments. Bullshit. I call bullshit.
Closer they are together, the higher the capacitance. The further away they are, the lower the capacitance, but the higher the magnetism. Now, let's talk.
Again, just more nonsense. This magnetism that barely even exists between straight wires. I mean, again, the argument is you have to coil the wire to get any real magnetism out of them. And the dielectric effect is exactly the opposite. That is, those are non-complementary magnetic fields. So they're useless. That's why they don't make motors that way.
Talk about a fact that, get down to brass tacks here, talk about practicality. We're not talking about
You're not doing any of that.
theory here, since a lot of people don't believe in black holes, but black holes are necessitated if you understand field mechanics.
Yes, they're necessitated. There's some sort of necessary thing. In what way would they be necessary? Nobody could ever, nobody could draw a diagram of any necessary role, whatever this mush is. Now, the idea that there's dense objects in the universe that we can't see because they're not on fire, sure, maybe so. But that's it. That's a black hole. There's no proof that it's the size of a grapefruit. We can't see grapefruits from millions of miles away. We can't see. Can't tell how big something is from millions of miles away. All we can do is detect radiation.
Fundamentally, at its most simplex level, and I've gotten this question many times. Someone will buy, let me actually draw it here.
Does anybody ever ask you why you're such a despicable coward? Do you ever get that question? Why you only pick on dead people?
Some will buy expensive magnets, say it's an N40 Gauss.
So he said this repeatedly over and over. There's absolutely no evidence. He doesn't show us a single experiment with his own magnets demonstrating this to be true. That somehow the inverse square law doesn't work, that somehow the rules of magnetism that are kind of written pretty solidly in terms of what we've observed over and over and over and confirmed over and over and over, that somehow those rules don't apply. And he's shown no evidence. So this is an extraordinary claim for which he provides absolutely zero evidence.
Yeah, an N40 Gauss, it's a rating. And over here we have the same size magnet.
So let's understand this N40 or N50 or N60, whatever that ratio, that just means the density of the magnetic material, the material that can be magnetized, in the percentage of the material in the ceramic magnet. So the magnet, it can't be made out of the magnetic material because it's not stable enough. So it has to be baked into a ceramic, neodymium magnets. And so they are doped, essentially. Only part of the material in the magnet is actually magnetic. The rest of it is just a structure to hold it, like a pill. A pill is full of other stuff to bind it. Okay, the amount of ingredients that are actually your medication is a small percentage of that binding material. So this is just telling you what percentage of the ceramic is the magnetized material and how effectively it's been magnetized. So I could take a piece of iron and I could stroke it once with a magnet and I'll give it a little bit of magnetism. But to maximize its the transfer of magnetism, I have to keep imposing magnetism and shake it or heat it, so I get all the little bits to line up. So it just really is just saying how hard did they try to magnetize the material, that's how magnetic it is. So you make it's harder to magnetize all of the material. So first you have to have a density of the material, and then you have to expose it to a longer duration of magnetism to get all the little bits to line up, and then cool it slower and do all these things to get the higher yield. But that's all it is. So you're just saying the magnet is stronger because within the volume of the magnet there's a higher percentage of well magnetized atoms.
Whether it be a disc or cylinder magnet, and it's like an N50 or an N55 Gauss. Let's say it's an N50. Let's say it's an N55 Gauss. Most of these over here at N40 are really about N38 Gauss, and let's say around.
So it's not a gigantic percentage. You're just talking about a 15 or so % difference in the quality of the magnet.
The N38 or N40 Gauss, we have so-and-so spatial footprint. Yeah? And this is what...
the spatial footprint is really, as Maxwell would have drawn it, is lines that come off these. These are essentially the charges, the north and the south. And you could just draw radial lines indicating this is the N charge and this is the S charge, and there's lines coming out. And where the lines mix, obviously you have a mixed field, where it's pure, you're going to have if there's an electron here, he's going to see more north, and that's going to mean repel. But if he's here, he's going to see more south, and so he's going to be attracted and he's going to be repelled. There's going to be a conflict between the two forces, and its movement will be weaker.
Confuses people. People buy an N50 or an N55 Gauss magnet, and lo and behold, what they'll discover is this neat little fact. And they'll send me emails thinking they got gypped, and they will ask me,
Let's understand you can ruin a magnet by banging it and hitting it and doing stuff to it to disrupt the alignment of the atoms, so they are vulnerable to losing their magnetism. But you buy a stronger magnet of the same size and it will have a greater reach. It's just a fact. You can't undo it.
why is the field so close around the magnet? I mean, I think I got gypped. I think so-and-so that paid me a bunch of money for a really powerful magnet gypped me because the field is far too proximal to the physical surface of the magnet.
So why don't you prove there's the R cubed rule doesn't work for this magnet, or why don't you take it and test its performance and prove somehow that the math is all wrong, that Maxwell was wrong about his math. Maxwell, a guy he's always citing, is one of the founders of this nonsense, even though this nonsense has nothing really to do with Maxwell. Maxwell didn't believe in toroids and hyperboloids. I don't see that anywhere. Certainly he didn't believe in it in the sense that he didn't write a paper on it.
And the reason for that is that nobody understands what this word is. Listen closely. There we go. No one understands what this word is.
Yes, and that and you are the biggest offender of the non-understanding, obviously. I mean, you couldn't misunderstand more completely. You have absolutely nothing right. You got the idea that there's an N and an S, but you don't even think they're poles of some kind. You don't even think there's a distinction between them. and everything you think is happening isn't happening. It has nothing to do with what actually can be demonstrated to be true about magnets with experiments.
Magnetism is the dielectric field. When people say...
So again, dielectric field. So we have a magnetic field, we have electric field, and we have dielectric fields. How many fields are they going to invent? And what are these fields doing? And how do they work? And what is... This is all bullshit. There's no field. What there is energy in the universe, radiation. It comes into these two things, and it either reflects or goes through, but the point is that one end ends up reflecting just one kind of energy, black, and the red, let's say the red is the south, and the south ends up getting all red because it just reflects red. And that's what a magnet does. It filters the energy that comes from the external universe. It doesn't produce any energy. It doesn't produce any motion because it has nothing to produce it out of. It ate no food. It can produce no movement. Okay, if you don't eat anything, you die. Magnets don't eat. Okay, they don't do anything. There's no source for their perpetual capacity to do something. They have a perpetual capacity to do it because they don't have to do anything. It's like a piece of filter paper. It doesn't do anything. Okay? I mean, it doesn't do the work. The work is done by the chemicals.
A really powerful magnet, they have no idea what they're talking about.
Right. You have no idea what you're talking about. You're just clueless and insane in the sense that you think you can prove an argument to rational people with this gibberish. Now, clearly, you can fool all of the humans all of the time. You've pretty much demonstrated it's not just a few of them who are foolable. It's like all of them are complete dupes, idiots, morons, cretins. Okay, they're just so frickin' stupid, dumber than the dumbest Native American who would, sell Manhattan for 38 beads. Or dollars or whatever. I mean, really, really dumb. So you can snooker them with this gibberish and they'll fall for it. You can make assertions that are overtly untrue, that magnets don't obey explicit rules in terms of their strength, that fields that magnets create are not disproportional. They're proportional, they're symmetric. More magnetism, greater field strength.
But that is okay. The more powerful a magnet...
More light bulb, more light. It's that simple. If I have a 40-watt bulb and a 50-watt bulb, there's more light coming out of the 50-watt bulb. It's going to bounce off more surfaces. It's going to create more reflections.
It is, the smaller its spatial footprint of its magnetic field.
Doesn't mean anything. So what does that mean? It doesn't. It's impossible to make any sense.
Field, because imagine, and I've given this analogy before because people have a hard time understanding this. And of course it doesn't work this way in real life. But imagine if you turn the water on to greater pressure or power on the output on your shower head. As a resultant, you'd get even greater suction. Of course, there's no suction in the drain in your bathtub, but imagine there was a suction and they were relational. The more you actually input the pressure, the more you actually
yes, more volume means more volume going down the drain. Oh, gee, that means something in terms of what magnets are doing, and that explains how the stronger magnet put less stuff in the drain somehow. I mean, the analogy is useless in explaining why these are different magnets in terms of how they perform. That somehow the rules of density of light. He's saying the 30-watt bulb and the 50-watt bulb. He's saying at a distance somehow the 50-watt bulb now is dimmer than the 30-watt bulb. That can't make sense, can it, to you? Do you people really think that makes sense? That as you get further away, you somehow can't tell the difference between the 30 and the 50.
Multiplicatively increase the vacuum of how fast it's drawing the water away. It's kind of the most simplex analogy. I could think of, and people don't realize that the more powerful...
It's a horrible analogy. It makes no sense at all. If I interrogated these 378 people and asked them to explain what that analogy referenced, they wouldn't provide a single clue.
magnet has, very, 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 very importantly, a much more powerful plane of inertia and dielectric centripetal convergence. Over here, it's weaker. It's not as powerful.
So whatever that is, right? Which there's no demonstration that it has anything to do with this plane of inertia thing. Has anything other to do with the fact that obviously from a charge's point of view, always, if there's going to be a mixture of exposure. You're exposed to as much positive as you are negative at these locations. And so obviously if I put another magnet there in the inverse position, it's going to attract, and in the opposite position, north to south, it's going to repel. South to south, north to north, it's going to repel. And it's going to do that because of this exposure to the force. And that's it. That defines what's going to happen to whatever you're testing with. And it just has nothing to do with what this produces beyond the fact that outside of it is where the two forces get mixed. Nothing's happening in here in the magnet. The magnet is a consistent matrix, all pointing in a direction. That is, all the atoms point in a direction, and all the energy that comes in, then the electron force, let's call it, goes one way, and the proton force goes the opposite way inside the magnet. But this point doesn't mean anything inside the magnet. The magnet is a consistent, the straight lines of highway, you could say, of the atoms being aligned, and the energy just travels the straight highways.
Yeah, and that is why the magnetic field is so voluminous, and it maxes out, and it also depends on the geometry.
So again, there's absolutely zero evidence of this. There's no way he can prove this. There's nothing. This voluminous field, that there's somehow, again, that you could go 5 feet from a 40-watt bulb and a 50-watt bulb, and all of a sudden the 50-watt bulb is getting dimmer, and somehow the 30-watt bulb is getting brighter. It's a ludicrous proposition. It doesn't happen. It's nonsense, and he gets rewarded for it.
The actual physical magnet itself, it's much more shallow on a spherical magnet for geometric reasons relational to the dielectric and magnetic that I'm not...
No, it's less on a spherical magnet because the alignment is obviously broken in a spherical magnet. You have a lot of short little lines, okay, because it all has to be aligned the same way. And a sphere doesn't create very good entrance and exit points. This a rectangular magnet creates perfect entrance and exit points. That is, the length. It wants to do the turn left, turn right thing. Obviously, it's a lot better for turning right and left if you have this shape than if you have a round shape, because the light going in will be more likely to come out the right way. It'll be turned correctly.
I can explain here because it would take too long, but it averages out between N35 to N40 Gauss on a magnet, where you end up with a decent sized spatial field around the magnet. And this is, of course, on a much infinitely larger scale how a black hole works. We're talking...
Well, whatever. It doesn't have anything to do with black holes and gravity. This is just absolute nonsense. There's no proof that this effect exists in the universe anywhere. It's just made up rubbish.
About something that's supermassive but has no magnitude. Because what people fail to realize, let me erase all of this, is that space is only like saying the farts of
Can my side be firm?
And my side's super soft with the Sleep Number 360 smart bed.
What a pile of
With your
crap.
Sleep Number 7.
Yeah. Pay me to
It senses your movements,
make
automatically
you
adjusts to keep you
stupid.
both comfortable. Sleep
Great.
Number. This is not a bed. It's proven
And
quality.
a forest
sleep.
ad, you can't click it out of it.
magnetism. It's literally the after effect of a centrifugal divergent force vector. There you go. Let's draw a little magnet here.
So that was more gibberish, the dielectric force vector nonsense. what there is a force, and it's just reflecting off one end differently than it reflects off the other end, and it's diverted at one end differently than it's diverted on the other end, because the two ends are essentially a profile of electron force versus proton force. And so you've just reduced the magnets, basically just showing you what an electron looks like when it's smashed against a proton.
We have centrifugal divergence here, yeah? And this, of course,
has never been demonstrated to exist at all as any force ever moving around the magnet. There's actually no evidence that a static magnet moves anything, that anything is moving in any direction around it at all. It's creating an intensity of radiation. Lots of dark blue coming out here, less blue here, more like purple here, because the red is mixing in with the blue, and then it gets less red and more red and less blue, and then and that's it. That's all that is. This is radiation, just like a light bulb coming off the magnet, straight lines, radiation, more pure, two color light bulbs. Just think of it that way: a red light bulb at one end, a blue light bulb at the other end. Obviously, you can see the two colors from some locations, and you only see one color from other locations.
this is a cross-section of the torus, which is the geometry of force and motion, and magnetism.
So again, it doesn't mean anything. So somehow this, whatever this is, I mean, it's got the arrows going both ways, so it's not even circular now. But somehow there's some quarter, both of this stuff is going this way, and it's creating some torus thing. And, all the way around like a donut. So it's a donut of some kind of something. There's not a shred of evidence for the existence of that. Nothing. I haven't seen anywhere any piece of evidence that demonstrates any such thing is happening.
Yes, if we actually extrapolate this out, we're actually looking at the cross-section of magnetism. This is the conjugate relationship.
You can put nothing in here and make it go round, make it do this circle. It will not travel this circle. Nothing will do that. If I put a magnet here in the right way, it goes right in. I put it the wrong way, the magnet flips over and goes right in. This is just horse shit.
This is also perfect example of the right-hand rule. This is the plane of inertia here. Specifically, is confined within the physical body of the magnet.
I don't know where's the right-hand rule. You got it going left, you got it going right. Where's any rule that it goes right? Where's the right-hand rule demonstrated here? The right-hand rule really is a consequence of the N being the electron side and the S being the proton side. And so obviously the N side is pushing electrons, and the other side is pushing protons. So that's the right-hand rule, because electricity is a movement of electrons, the vibration of electrons.
Right here, and 90 degrees contrary to that, and makes the perfect cross. And that.
So again, anybody could just make this. I could make this little square into a rhinoceros. I could put little eyes on here. I could put a little horn on it. I could make it into anything. There's a perfect cross in here somehow. Yeah, I guess you can do that to any square you draw in the universe. If you're so inclined.
Actual cross, not like a Christian cross. Okay. 90 degrees conjugate to that. We actually have the force vector of force and motion. Of course, this is the force vector of increasing inertia and acceleration, which
so again, it just draws this crap. Now, nowhere in this crap will you get any understanding of how two magnets, when they're opposing each other, are two atoms, because that's where the magnetism starts, of course, where any of this stuff is happening and where any of this stuff would create attraction and repulsion. There's absolutely no indication of how all this crap creates rather intense. I mean, stronger and stronger the closer they get. The force increases the closer and closer and closer, or the amount of force, the amount of repulsion, or the amount of attraction. This doesn't explain any of that. How does any of this do any of that? It's not even a diagram that explains the effects. And as a cause, you're saying What's causing all this? What is all this coming from? Where is all this? Where's this stuff? What is this stuff that's moving? And how does it know to move in this funny pattern? What's making it move in these funny patterns? What's doing any of this? No explanation. It's just some sort of magical effect the universe has, is that it does this magical swirly crap for no reason, for no physical reason.
Which is centripetal convergence. When people say, I bought a more powerful magnet, therefore I think that the magnetic field over here, represented by blue, is going to be bigger.
So he's even conceded that magnets break into magnets. So why don't you explain how, when you have a whole bunch of these stacked on top of each other, that somehow these things make the magnet even bigger and make the hyperboloids bigger and all that, that somehow amplifies the effect. There's no explanation for how this amplifies anything. From my theory, it's obvious. Obviously, this stuff goes in, it goes right, or it goes left, depending on what it is, or it reflects off the surface. So obviously, you magnify the effect as you stack more and more on top of each other. You're creating more and more reflections. It's making the mirror bigger. So obviously, it would work. How does this work? How does stacking these on top of each other make a bigger tornado and a bigger donut? How does any of that happen? There won't be any answer to those questions.
And it's exactly opposite to that, because power, force in motion is the impotency of power. When you set off a fire...
So force in motion is the impotency of power. It's the opposite of power. So this is the opposite of power, and this is the real power or something. I don't know. What does this gibberish mean?
Firecracker, yes, releasing the power of a firecracker, right? Right? That's correct. When talking about the conjugate field geometry of the dielectric and magnetic, which are...
Again, so this is, we don't know that's all a chemical process of just putting stuff that's highly flammable, so to speak, that will oxidize insanely fast in a little container, and then you oxidize it very fast, and it happens very fast, but it's in a small container, and the container can't, it tries to hold back the pressure, so the pressure builds up because it's trying to maintain its integrity, but eventually it's too much for the package rips and tears, and then the explosion happens unevenly, and depending on where it tears and how it tears, and the pressure is released.
Said magnetism is the dielectric field. It's literally the loss of inertia, the loss of true inertia by original denotation, not...
Okay, so true inertia is lost, whatever the hell true inertia is. So again, he uses a regular word like wet, and then he says, well, wet really doesn't mean wet, it means dry. Really. Okay, so, what point is there in this nonsense? And again, highly rewarded for just saying things like, well, it's not, I don't mean inertia like everybody knows what that word means, like every way you've ever heard it. I mean inertia in a whole different way. What good is this nonsense?
Current connotation of inertia as a manifestation, and of course everything here within the toroidal, this after effect of a divergent field is space, but space has no properties, and this is why this is why Nikola Tesla called Einstein a fuzzy-haired crackpot.
Space has no properties, I would agree, right, and Tesla was right to say to Einstein, space has no properties, but clearly you're giving it all kinds of properties. I mean, clearly, you're calling it all kinds of things, you're making it into something, so why are you saying it doesn't have any properties when you claim it does have all these properties, where it can do all of these things? Tesla was talking about empty space. Has no properties.
Because the big S here is what relativity and Einstein reified as having properties and acting upon other things, and we see all that.
Einstein didn't say much on magnetism, so again, this is just sort of such bullshit to combine these two things as if Einstein's relativity theory has something to do with this magnetism explanation, when those are really two different subjects, aren't they? I mean, completely different subjects.
The crap in our science fiction movies, the so-called bending of space and time, which is a complete absurdity.
Yes, you can't bend time because it doesn't exist as a thing you can bend. It happens second by second. There is a universal clock. It works. Everything is obeying it, and especially photons. Photons are the universal clock. There's no photon somewhere moving slower, and no photon somewhere moving faster. It's just not happening.
But understanding when you're actually buying a more powerful magnet, what you're actually doing is you're using this vacuum or suction analogy as opposed to a flow. And we actually, and this is the various most simple manner in which I can explain it to people, is that where they actually understand it seemingly every time. I'm going to use simple analogies because we're actually talking about conjugate.
There's no simple analogy, okay? You're making an assertion, you ought to defend it with evidence. You're saying the 40-watt light bulb isn't brighter. The one using more wattage is somehow less bright. It has less, those photons are weaker and they can't travel 10 feet.
Geometries of field modalities is that we're, damn iPad, we're talking about force and motion and inertia and acceleration.
So you're just going to draw the same thing. So you erased it so you could redraw the same fucking thing. And we're talking about it, yet you're not explaining how all the little hyperboloids in here somehow make a big hyperboloid out here. No explanation at all. How a bunch of little tornadoes make a big tornado.
Let's draw the red here. Plane of inertia right here.
Same bullshit.
This is increasing inertia, right? Increasing pure potential. This is counter space. Right here, where's counter space at?
So this is space, and this is pure inertia, I guess, because counter space would have to be there has to be space if there's counter space, and so it's like saying unnothing, unsomething. So this is how bad the language is. So instead of saying nothing, you say unsomething. That makes sense to you people? No.
Yeah, it's right here. Same thing as a black hole. This is why a black hole has no magnitude, because the dielectric, i.e. I have represented here in red, overthrows completely 100% magnetism's ability to keep anything within the visible universe, because this right here.
So somehow the tornado destroys the donut and there's no donut anymore. That's what black holes, that's why black holes have no magnitude. They don't do anything.
Is the visible universe. Anything has volume and magnitude due to one thing and one thing only, and that's magnetism. And if you have something such incredible power that...
Right, and so why don't magnets produce light then? If magnetism is something to do with black holes, why does light escape magnets? Yo, this just doesn't make any sense at all. There's just nothing to... You can't make any sense out of this comparison.
Dielectricity is overthrown magnetism, then what you end up with is this. Hold on a second. You end up with this. This in black. Yeah.
All right. So does that? I mean, it just doesn't make any sense. So somehow everything disappears. The tornadoes disappear. The donut disappears. Everything disappears. Even though you've increased the amount of stuff here, somehow it all just disappears, and is nothing, and it doesn't do anything anymore, except make a ton of gravity.
You end up with a supermass with no magnitude, which we have no analog for here in our visible universe.
We don't have any analog in the invisible universe. I have nothing to compare that to. It doesn't fit any theory of black holes. It doesn't fit anything I've heard from anyone else. It's just something you made up. You're saying this is what it turns into by some process you didn't explain and through some mechanism that's left unknown. Okay.
Because magnetism, which would be out here, having mass and volume to something, does not exist. It's literally been overthrown by the dielectric. And simply even look...
So, whatever. I don't think there's any theory that somehow black holes can't be magnetic, but whatever. It's just all just made up nothing. It's just And it's not even interesting made up. It's like the Bible. It's not even an interesting story. I mean, it's certainly not an interesting setup in terms of there's no talk about anything that does mean something to people, in the sense that, the parts that we cherish the most are the ones despised the most in their perfect world. And it's like, well, why do I want to go there then? What's the point? I go there to just sit around and watch children laugh and wait in line to kiss Jesus' feet. What do I do all day in the fun place called heaven? Hey.
Looking at light here.
I mean, I suppose if you're impressed by rubies and diamonds, it means something. Because apparently the whole island of heaven is just encrusted with a bunch of rubies and diamonds. So if that turns you on, I guess, you can just sit there and rub them all day. Ooh, shiny, shiny.
Smaller the space, the higher the capacitance. If you want to think of capacitance as power, it's analogous. But
again, it's just nonsense. I state the only relationship between size is the idea of pressure, compressing something. But that's it. It just has nothing to do with the capacity of something. It has to do with the fact that you're compressing something, to bring two things in contact with each other.
let's draw out, you think, well, this doesn't have much power compared to infrared or red light. Yeah, I mean, look at this. This is huge. So which has more?
So again, he drew the proportions wrong, and the understanding would be is that the lumps are supposed to have the power. He says the nodes are where the power is. Well, the nodes are the same size in both of them, so that doesn't even make any sense. But anyway, the point is that obviously the part of this thing that is interesting, or would have whatever you want to call momentum in it, the momentum portion, would obviously have to have something to do with the bumps and how many there are.
More power, this or this? Well, the answer is this. This has a tremendous amount more power to it. And if you start moving...
So if they were water waves and you knew the waves were all the same size and there was twice as many waves coming, you can figure it out. Yeah, obviously that's more energy. Took more energy to make them, and they're gonna bounce me around more if there's twice as many of them. Duh.
Further this direction, you end up with this neat stuff that's shooting out of the central reactor of Chernobyl, and it's called, it's nothing other than high energy light. It's called gamma.
So it's just light, photons. It's just electromagnetic spectrum stuff at a frequency, and the frequency is high. That's it. Nothing miraculous. Lots of little cannonballs close to each other. Yes, that's more than few cannonballs far apart from each other. That's it.
Gamma radiation. That's all gamma is ultra high energy light. And I know for certain, and I've given it years and years and years of thought, somewhere to the...
So he gave it years and years and years of thought, and he still can't draw the proportions correctly. And he can't draw the waves correctly. I mean, you should know that magnetism is 1,000,000 times weaker than electrical waves, if there were such things. Like I said, I think there's one field, and nothing perturbates in anything more than one field, and the field isn't a field of nothing, it's a field of something. It's energy. There's little bits in the field. The little bits are all moving. They can be moving towards you, or they can be moving away from you. That's kind of important.
Order of, 30 to 100 magnitudes higher, powers of 30 or 100 or higher of gamma radiation, we actually have the fundamental particle. And
You actually don't. There's no evidence of any such infinite ability to go anywhere, and there's a point, that's it, that's the highest radiation. The point is there's proximity problem, the Planck constant. You fall into a place where, yes, you can't divide the space anymore between two things. I can move two electrons towards each other, and there's a space that's too close for the photons to even bounce back and forth anymore. But that's all we're really talking about.
We actually see this being emitted from galactic jets at the centers of various galaxies and from black holes. It's nothing other than ultra high energy light. I mean, that's all a fundamental particle is.
Yeah, well, we really can't see it. So, but anyway, go ahead.
So when we talk about reconciliation of light and matter, well, they're already reconciled. It's that human beings didn't understand it until now, and that's all the fundamental particle is a super high energy form of light, which would actually make it also a ZTP. You can look that up on a Google search if you like. It's called a zero time particle.
Yeah, more just made up rubbish, bullshit, blah, 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 blah. So he's accepting zero time particle. He's accepting that's existence when that's more Einsteinian. I mean, that's not Einstein's fault. That's the fault of the people who are Einsteinists, putting that crap in Einstein's mouth, so to speak.
Anyway, thanks so much for watching. Just remember the important thing, and that is that the smaller the space, the higher the capacitance.
The more cannonballs, the more ruined your house is. Okay, I have to tell you that. You can't figure that out on your own. The more cannonballs, the bigger mess my house is. Okay, I can't figure that out on my own.
And all of Mother Nature follows this. This is the conjugate geometry and the right-hand rule of...
Yeah, he didn't explain anything right hand here. He didn't show us any right turns or any reason for a right turn or any of that crap. He didn't... nothing. No explanation for why one end of the magnet is pushing electrons and one end is pushing protons, clearly. That's the origin of the right-hand rule, but there's just no... He didn't make any of those connections.
Not only magnetism and dielectric, but also of light. We have a tremendous amount of power here, and we have very little power here. So as volume increases in this direction towards the infrared, power goes way down. So
again, there's no volume here. There's distance between lumps. There's no volume.
As volume increases here, power decreases. As volume decreases, power or capacitance greatly increases. So all of the universe works like this, and light does, and
there's just no evidence. So again, just nonsense, gibberish, bullshit. Nothing, no citation to any experiment that demonstrates any of this toroid, hyperboloid, anything, any of it existing. Nothing. Highly rewarded. It's just a sign of idiocracy. I mean, we're in idiocracy. It's bad. Big trouble. Okay, this is what the average photographer. They can't figure out this guy's full of shit. Seems apparent.
Powerful versus non-powerful magnets work like this. Everything works like this. Thanks for watching.
Nothing works like that. Nothing has anything to do with this crap. It's all horrible bullshit, and he's a despicable coward because he will not allow himself to be publicly challenged on this nonsense. These idiotic assertions of who's an idiot. So, that's all we got. I guess I'll have to listen to this Sean Carroll thing. Eek. So, the physics, if you go to these real experimental people, you'll see that none of this crap is true. Till you get to wackos like this, whatever, Al-Kahari guy. He doesn't say hyperboloid, though. He still didn't go for that. But it's pretty wacky. So anyway, another depressing morning. Thank you for obliging me to do this crap. Bastards. Jeez. I hate this planet. It's just such a shithole. full of shitheads.